Centripetal force is required to keep orbiting objects continuing in their path. If centripetal force is not present, the ball will shoot out in a straight line. Just like the Earth goes around the Sun, centripetal force keeps it in its orbit. In this lab, we're going to use this force, discover it, and see what happens when it doesn't exist. For this lab, all you need is this bag that has the components in it. If you take out the Take two. For this lab, all you need is the bag of components, which includes a globe, a glass tube, a string. Okay, here's the globe, the glass tube, it's taped, a string that's all wrapped up, some heavy-duty washers, and a little homemade clip that's made out of paper clip. As you unpackage it, slowly, unwind the string. Make sure it's not all tangled, and let it kind of untwist itself. It's going to be all wound up. Make sure it's steady, and then we can start the lab. A couple precautions before we get started. This glass tube is used to allow the string to slide in and out. So the weight of the washers pulling on this hook will be able to pull the string through the tube, and the other end of the string can go to the globe, which will be spinning over your head. It's a glass tube. Don't squeeze it so tightly that you'll break it. You can cut your hand pretty badly. Also, don't swing it so wildly that you're hitting people, hitting things, hitting each other, hitting other globes, hitting the glass that's in the room. Just take some caution as you're spinning this. Now, what you must do is you're going to start out with just 2 washers on here. If you look at the data table in the Google Doc, it goes 2, 4, 6, 8. Start with 2. And you're going to spin the globe over your head. And you have to start out slow and get it to a steady state where it's just spinning and it's holding the weight without it. The weights are just hanging here now. I know you can't see that on the camera. If I spin faster, the weights will rise. If I spin slower, the weights will pull the globe in. So you want to find a nice steady state. Then one of your partners will time 10 full revolutions. So it'd be 1, 2, 3, 4, 5, up to 10, and someone's timing that entire time. Then you divide that time by 10 to get the time for 1 revolution. So you're doing 10 to get some averaging. Okay, then you're going to take the hook, enter data on the data table, take the hook off, put 2 more washers on, okay, hook it back up, and do it again. Now there's more force pulling down on the string. So what do you think you have to do to that globe to keep that weight up? That's part what you got to figure out. Then you do 6 and 8 also. Make sure you get a nice steady state going, and you do it for 10 revolutions, and someone's getting the time for those 10 revolutions. Enter the data into the table, and then that time for 10 revolutions, you'll divide it by 10 and put that into the column on the far right, because that'll be used to answer some of the questions. That's it, guys. Have fun.